What's up, guys? We're going to do a lecture today on SMAW, shielded metal arc welding, also known as stick welding. So in this video, we'll cover the machine setup, how the arc works, polarity, technique, electrode classification. We'll try to cover just about everything to get you started in understanding kind of the theory behind the process and how it works. So we're going to go ahead and jump right into it. The first thing I'm going to talk about is machine setup and the basic concept of the process and polarity. So shielded metal arc welding, the reason why we call it shielded metal arc welding is because we have a flux covered electrode, which is basically a metal rod that's covered in flux. And what that does is that flux becomes a gas and it protects the weld pool from the atmosphere. Contaminants like oxygen and nitrogen that are in the atmosphere and the air, if they're just exposed to the molten weld pool, they will contaminate that, cause porosity and all kinds of issues. So there needs to be something that will protect the weld pool. So in this case, we have this flux coating that will provide that. So that's where the name shielded metal arc welding came from. It's also known as stick welding. Because it's basically a stick electrode that is used, and it makes it a very easy portable process because basically you have everything that you need in that electrode, the shielding gas and the filler metal. It's very portable and it's a very simple process. There aren't a lot of extra components you need, like gases for shielding and regulators and bottles and things. Basically, you just need a power source, a couple of leads, electrode holder, and some electrodes, and you're good to go. So that's why this process has become, I wouldn't say it's become, it has always been very, very, very popular for field welding, and just all around, produces good quality welds in a variety of situations, and is very, very popular. So it's not really going anywhere anytime soon, even though there's other processes now that are more productive, faster, more semi-automatic processes and things like that. Stick welding is not going anywhere anytime soon because of its simplicity, and it just provides good welds. So we're going to go ahead and get started here on the kind of the basic setup of your machine. So basically we're going to start with our power source. This would be your welding machine. The type of power source that it is important because there's basically two different kinds of power sources. There's what's called a constant current power source and a constant voltage power source. In this case, we're using a constant current power source for SMAW. Another word for current is amperage. And we basically only have one parameter that we adjust on the machine for SMAW, and that would be amperage. So what this machine does is it tries to keep that current amperage, it tries to keep that consistent. It provides a high voltage to get the arc started, so it has a high open circuit voltage, and when you make contact with the base material, it will get the arc started, and then that voltage drops off, and it tries to keep a consistent amperage based on what you have it set at, no matter what the welder is doing in terms of how far away they're getting, how close they're getting to the work surface. That machine is going to try to keep that amperage consistent. So we're going to be using a constant current power source for SMAW, and amperage is our main parameter. Now, basically, amperage is going to translate to heat in our weld pool. So if we turn up that amperage, we're going to get more heat in the weld pool. If we turn it down, we're going to get less, right? So that's basically the way that works. Now, polarity is a big deal, and it has a lot to do with where our heat will be focused in the arc itself. And just about, certain electrodes will need to be run in certain polarities. So it's really, really important for you to know as a welder what polarity you're using and how to change that, how to figure that out. Because I come across a lot of welders who, have been welding for a long time and they don't even know what polarity that they're using. And that can be an issue. So in this case, The electrode that we typically start off using, in my classes at least, is a 7018 electrode, which is kind of the industry standard for structural applications. And that electrode is designed to be used direct current electrode positive. Okay, so what that means is, just like it says here, direct current electrode positive. Luckily, right in the name here, we can see that we're supposed to use direct current and that we're supposed to attach the electrode to the positive terminal. So on this power source, we have a positive and a negative terminal. So again, electrode positive, we'd want the electrode holder or the stinger connected to the positive terminal. That means that our negative would be connected to the ground clamp. Okay. Alternative to that is direct current electrode negative, which would just be switched, right? Electrode negative. So then we would have the negative connected to the stinger rather than in this case. And that just works differently. It has a different area where the heat is focused. And some electrodes are going to be designed for that. For the most part, most of the stick welding electrodes that you're going to come across that are used a lot in industry are going to be direct current electrode positive. Okay, there are some alternating current electrodes or some that can be used both ways. Alternating current is a little bit harder to keep the arc stable because you have that polarity switching between the two sides very, very quickly. This is, again, kind of the industry staple in terms of polarity. You're going to come across most of electrodes are direct current electrode positive. So now let me talk a little bit about how that actually works in a direct current electrode positive situation and where that heat is going to be focused. So in this circuit, this is basically an electric circuit, right? There's electricity, electrons moving through this circuit. And in this case, electrons always move from negative to positive, okay? That's something to remember. And this will help you to understand where your heat is going to be focused with different polarities. So your electrons always move from negative to positive, just like your attitude should always go from negative to positive, right? Just like when you're welding overhead in, shorts and a tank top with flux core, your attitude should always go from negative to positive. Never mind, that's a bad joke. Anyway, you get it, right? Negative would come from the negative terminal. It will make the jump across to the electrode and continue negative to positive. So this is the direction that the electrons are moving in this case, in a direct current electrode positive type situation. So how we know where the heat's going to be focused is if we were to blow this up, and this is the end of our electrode, and this is our arc, and this is our base material. In this case, the electrons are coming through the base material, and then they're making the jump across to the end of the electrode in the arc. Where it makes the jump across, where it actually encounters the other side of this circuit, okay, is where the heat is going to be focused. So in this case, about 70% of the heat is focused in the electrode, okay? So for direct current electrode positive, our heat is going to be focused mostly in the electrode, okay? So that's the way that this electrode was designed. Having the heat focused in the electrode will help it to release the gas, to provide the shielding, and otherwise it's just been designed to provide a quality weld and good deposition with this polarity, okay? So it's really important. You want to look up the polarity on electrode that you're using. If you're not familiar with it already, make sure that you know what polarity you're supposed to be using and use the proper polarity, okay? So that's the basic setup for stick welding. You have a ground clamp which attaches to your workpiece, and then an electrode holder which attaches to the electrode itself. Okay, so next we're going to talk about the basic technique for stick welding. There's a few different things that you're going to want to look at as you're welding that are going to affect the quality and the appearance of your weld. So we'll get to that next. All right, now we're going to talk about technique. And there's, with basically any process, there's going to be 5 things that will affect the quality of your weld and the appearance of your weld. And that would be angles, as far as travel angle, your work angle, those are 2 different things, your arc spacing or arc gap, your travel speed, and manipulation if you're doing any type of manipulation. I'm going to go through each one of these things and talk about how that'll affect the quality of your weld and what you're seeing in terms of the appearance of the weld. So we're going to start with the angles here. Okay, so with stick welding, we have with any type of process, we have a travel angle and a work angle. So the first thing is our travel angle, and that's in relation to travel. So if we were starting here with our weld and we were going from the left side of our joint to the right side, you know, we're welding along this way, along this joint. With any type of process that has slag, we're going to drag. So we're going to be dragging along, and the weld pool will be trailing behind the electrode as we weld, okay? And in order for the slag to do its job properly, and in order for us to get proper penetration and stuff like that, we need to drag with this process, okay? The exception would be when we start to go out of position, like when we go vertical up, we might use a slight push angle, but we'll get into that later, okay? For right now, just remember in the flat and horizontal positions, we're going to be dragging, okay? All right, so we can see that from this diagram that we're not going to use a straight up and down travel angle. We're going to use a slightly angled travel angle. So at about 20 degrees is what we want to hold the electrode at as we're welding along. Okay, so just a slight drag angle is going to give us the best profile to our weld. Now, if we vary from that, we're going to see, you know, if we get to the extreme over here, we're going to see that in our weld. We're going to get a higher, more kind of piled up weld because we're going to be directing the heat from the arc and the weld metal that's coming off the end here onto our weld metal rather than into the base material and really welding it all together, right? So this is very, very important. All these things are very important. So that's where it's kind of trying to remember all these things at the same time and developing that muscle memory just to do it the same time each way is really, really important, you know, when we first start welding. So travel angle, about 20 degrees dragging, okay? Our work angle is in relation to the work piece. Okay, so in this case, with a T-joint, we're going to have about 50 degrees, so just slightly lower than 45 degrees. That way, as our weld metal is being deposited in this corner, as it cools, it comes out nice and flat. And if we go to the extreme, either way with this, we're going to start to see our quality start to lessen because, you know, if we're way too low on our angle here, then we're going to be directing most of the weld metal to this top member. Or if we have it too high, then we're just depositing more weld metal on this bottom member. So to get a good profile with equal leg lengths of our weld, we want to make sure that we're kind of right in the middle of that joint and just a little bit lower than 45 degrees so that it deposits it right in that corner and it comes out nice and flat face to it. Okay, so work angle is also very important, and being able to maintain those angles as we go through is going to be very important as well, because that's the difficulty, right? We may start out with our angles right, but as we start welding, our tendency is to start to roll our wrists or something like that. So we really need to lock in these angles as if our hands were locked into, you know, some sort of machine that is not going to change as we go through. Okay, so try to keep that in mind. Now the other thing is our arc gap. So that would be the distance between the end of our electrode and the work surface, okay, or our arc. And that is very, very important, especially with stick welding, because as the end of our electrode gets further away from our work surface, the arc gets hotter and more erratic. Okay, so I'm going to repeat that. As we get further away, we get more resistance in our arc, and that creates more heat, but it also makes the arc more erratic. The weld metal starts to fly all over the place, a spatter. It doesn't deposit where we want it to go. It creates undercut because that arc is kind of wandering around because it's trying to find the path of least resistance. So we need to make sure that we're maintaining a very short arc gap as we progress through the weld. Now, keep in mind, this is a consumable electrode, right? This metal rod that's inside of here gets burned away as we're welding. So this is another thing that's hard. And I see a lot of new welders that, as they're welding, this thing is burning away. They're doing okay with their travel speed. They've got their angles okay. Well, now, they have to think about feeding in this electrode and keeping that arc spacing nice and tight as they're going through, as they're getting to the end of the weld, okay? So always be trying to watch the arc spacing as that electrode burns away and keep it nice and tight. That's going to give you the most control. And it's also going to give you the most control, it's going to give you the most control in terms of where your weld metal is actually going, but it's also going to control the heat in the weld pool. Get that long arc, it's going to start to get real hot and erratic, and it's going to feel out of control, okay? So try to maintain tight arc spacing or an arc gap. Now, travel speed. Travel speed's pretty self-explanatory, although I see most new welders in any process, they just are going way too fast typically. They aren't really giving the weld pool a chance to fill up. So just keep that in mind if you're running your first bead ever, go slower than what you think. This, especially with stick welding, once you get the arc started, which can be kind of difficult when you're first starting, maybe you're a little wary of it, or, it's the first time that you're welding, so that arc flashes and, you got your PPE on, but it's still a little bit scary. So what I see a lot of new welders is once the arc starts, they just, want to get to the end of that weld. Get it started, let that weld pool fill up, keep a nice, slow, steady pace, let that weld pool form, and try to maintain that same travel speed to keep that size consistent of your weld throughout the entire weld. Okay, so you can also take a look at what you're actually seeing in the weld when you're done and make a determination based on that. Just for instance, if your weld profile, if you're looking at it from the top and it's a very, very large kind of just piled up weld that's real big and wide, then okay, maybe my travel speed is a little too slow, or maybe it's not consistent. I'm going fast and slow and fast and slow, so I need to try to maybe speed up just a little bit but keep it consistent. If it's very, very thin and just kind of irregular and just kind of sitting on the surface, then okay, maybe I'm going a little too fast. I need to let that fill up and then trying to maintain that speed as I go forward. Okay? Travel speed, very important to the appearance of a weld. And then the next thing is manipulation, which is any type of, if we're doing a weave or if we're doing like a C pattern or cursive E's, there's a lot of different things that we can do to get a different appearance and different quality to our weld. Really, an acceptable weld is an acceptable weld. If we have a good profile to our weld, meaning like in a fillet weld, our profile should look something like this. If this is a T-joint, the corner of a T-joint, we want to see a profile in a perfect world that looks something like this. We have equal leg lengths. So these lengths from here to here and here to here are the same. And we have somewhat of a flat profile. This is perfectly flat, a little bit rounded that way or just a little bit concave is okay. That's going to be an acceptable weld. So it doesn't really matter how we manipulate the electrode, if we're just going straight across, if we're kind of going like a pause and a stop, an advance and a stop, almost like a little bit of a whip, or if we're doing cursive E's or C's or a W pattern. It doesn't really matter as long as we end up with an acceptable profile. An acceptable weld is an acceptable weld in the industry. Okay? Now you may come across a shop or your supervisor or whatever only wants you to do it one way, and there may be a reason for that. So that varies. But in terms of the way I teach and the way I do inspections is, as long as you have an acceptable weld, it's an acceptable weld, and we're going to move on, okay? There's no reason to fix welds that are acceptable per industry standards just because they have a little different appearance or something like that, okay? That's my take on that. Manipulation, though, I would recommend if you're welding for the first time, just try to be consistent first of all, okay? Get a consistent bead just dragging straight across, okay? Then later on you can develop manipulation that maybe gives you a better profile or a better appearance to your weld, or you just prefer it. But at first, try not to complicate it because you'll be doing different things and getting different results, and you won't really know if it's your manipulation or what it is. So just stick to these common things and try to drag straight across and see if you can get a consistent size and a acceptable appearance and profile to your weld. And then from there, you can develop some different things, okay? All right, so that's about it for your technique. Now let's talk about electrode classification next. Alrighty guys, so now we're going to talk about electrode classification for SMAW electrodes. And the reason why we have electrode classifications is right here on the electrode. Well, you can't really see it, but right here it says E7018 electrode, okay? And that's basically a number letter combination that will be printed right on the boxes, the labels of the electrode packaging on the electrode themselves a lot of the time. That way we can't be confused about what we're using and get into trouble and accidentally use the wrong electrode on something that's a critical weld, right? If we're out there welding bridges, or buildings that people are working and living in every day, we want to make sure that we're using the electrode that's been tested and has been deemed safe to use for the application, right? It's a proper tensile strength. It's going to create a quality weld, right? So we have these electrode classifications to make sure that, if it looks the same, but maybe it's not exactly the same, that we don't get mixed up. So in this case, we're talking about an E7018 electrode, which I've written up here, and I'm going to go through each one of the digits here and what that means. Now, if you're taking my class, you have a handout that's available in there that says electrode classification that has a similar thing written up in here, and then it also has lists of various electrodes and what the differences may be. But we're just going to go through it visually here. So the E that's in the electrode classification stands for electrode, current carrying electrode. Now for some other electrodes and filler metals, we might have an ER, which means that it's electrode or rod. It can be a current carrying electrode, or it can be used just as filler metal. Those are bare electrodes, like for GMAW or GTAW, MIG or TIG. But in this case, we just have one option, which would be a current carrying electrode for SMAW, meaning that the current goes right through this, and it's also the filler metal for the weld itself, okay? So electrode current carrying, okay? After the dash here, we have two numbers, 70, 60, could be a variety of things, but that stands for our tensile strength. So that's the actual weld metal is tested. So the metal rod that's inside of here, they take a sample of that metal, they put it in a tensile strength tester, and they pull it until it fails, right? Until it breaks. So this electrode is at the minimum rated for 70,000 psi. So this is the tensile strength. These two numbers would be the tensile strength in KSI, which means just thousands per square inch. So that translates to 70,000 psi. So it's a good, strong structural electrode, 70,000 psi tensile strength. That's pretty strong, okay? The next digit here has to do with the position that it can be used in. So different electrodes are designed to be used different ways in terms of the positions that they can be used in. Some of them are what's called a fast fill, which means that it's designed to fill the weld pool as quickly as possible, but typically those are not meant to be used out of position. You can't use those vertical up or overhead typically, right? Because it's fast fill, it doesn't, the weld pool doesn't cool fast enough and it will drip down, either produce a weld profile that's unacceptable or just fall out, right? So this electrode, being a 1, stands for all position, okay? So that means that this one can be used flat, horizontal, vertical, and overhead. Okay, it can be used in all positions, which is another reason why this particular electrode is a staple in the structural industry, because when you're building a building out there or something like that, you know, you can't flip the building upside down to do your welds that are in the overhead position in the flat, right? So this one is all position. Now another option would be a 2, which would be a limited position, which are typically only going to be used in flat and horizontal position because that's a fast fill electrode. This would be considered like a fast freeze electrode, which means that the weld pool freezes quickly so you can use it in all positions. Okay. The last digit here is the flux coating, what makes up the flux coating, and then also by that you can look up what the polarity should be. Now in the handout I was talking about for my classes, it has a list of all the different digits that can be there, what the flux coating is made from, and what the polarity is. Okay, so you can reference that and take a look at that there and get some more information. Now after this, there can be some other information, like you can have a low hydrogen electrode, like an H4R electrode, which would mean that there's some other requirements in terms of storage and things like that. So there are some other things that can be there. So you would always want, if you're unfamiliar with an electrode and what the electrode classification means, you'd want to look that up by the manufacturer's recommendations, and it'll tell you all the particulars, you know, the specs and the recommended usage for that electrode, and that's always a safe way to go so that you're using it properly, you're storing it properly, and that sort of thing. This is what's called a low hydrogen electrode. So per the structural code, it has to be, if the package is open, hermetically sealed package is open for a specific period of time, then it needs to be stored in an oven at a certain, at a certain heat to make sure that all the moisture is taken out of the electrode, so that all the welds are quality that's up to the code standard. Okay, so you want to pay attention to that as well. So some of the other electrodes that we have here that I wrote up here are just some different electrodes to give you an example. We were talking about the 7018 electrode. Another electrode is our 6010 electrode, which is very, very common in industry too. This is a very good penetrating electrode. This is used a lot in agriculture and farming. You know, this is a great electrode to take out into the field and repair, you know, a fence post that's covered in paint or rust, because it'll really penetrate. It's not going to give you the prettiest weld, but it'll give you a good quality weld that will be strong, and it will penetrate through rust and paint and that sort of thing. This is a great rod. And if you'll notice, though, there's a little difference in the electrode classification. So what do you think that is? Just by glancing at this, first thing, what would be the difference between a 6010 and a 7018? Tensile strength, right? 60, that would mean that this has a tensile strength of 60,000 psi, whereas the 7018 has a higher tensile strength. Now they do have something in common. The position, they can both be used in all position, and obviously they have different flux coatings. This flux coating is actually almost like a paper. It's a cellulose flux coating, which is a little bit different than the 7018, and has a real particular smell. That always brings me back to welding with 6010. It's kind of a different smell. Anyway, Now the next one that we're going to talk about is a 7024. Okay, so this is a 7024 electrode, what we call the mud rod, lay rod. This is a different electrode, right? And one of the reasons why it's so different, if we can take a look at this electrode classification 7024 compared to 7018, what would be the major difference that we should see right away and notice about how we should use this electrode? The two, right? This is a limited position electrode. So this electrode can only be used in the flat and horizontal positions. This electrode is very, very different from other stick electrodes, where most stick electrodes, if we get the arc started and then we make contact with the base material, it's just going to stick to it. This is what we call a lay rod. So basically, you get that arc started, and you can just kind of lay it right on the plate, and it just very, very smooth. That's why it's called the mud rod. Just kind of lays in there like mud, and you just lay in that weld as you go. So this is more of a production rod. It's very, very easy to use in the flat and horizontal positions. You know, you can just lay it right in that weld pool and lay down some high deposition welds, meaning you're putting down a lot of weld metal very quickly, and it's very user friendly. So this would be a 7024, still 70,000 psi, but now it's a limited position, and then it has an iron type flux coating, so it's a little bit different as well. Okay, so those are three electrode classifications. It's going to be important for you to at least know how to tell the difference between different electrode classifications and be able to look those up just to, for your own safety, and making sure that anything that you're building is you're going to be using the proper electrodes and the proper polarities to achieve good quality welds on whatever you do. Okay? Alrighty, we'll catch you later.